cost curves. So first we have to just get some basic definition. What are fixed costs? Fixed costs are the cost for fixed resources, which we just talked about in the last video. Fixed resources is your land, your capital, things that when I increase the quantity I'm producing, I don't actually have to increase the amount of these. So electricity falls into this, most utility bills. These are costs that don't change when I'm producing more. If I'm making more pizza, I don't need more electricity necessarily than I was having before, or more internet, right? That's the idea. So it's the cost of those fixed inputs needed to produce. That's fixed cost. It doesn't change, right? And even when I'm producing zero, I still have fixed costs. Now, our average fixed cost is our fixed cost, total fixed cost, divided by the quantity. And so when my quantity rises, my fixed cost doesn't change. So average fixed cost actually gets less and less and less because I'm dividing the same number, that fixed cost number, by a growing quantity. So we can see that right here on the graph. As you see, average fixed cost getting closer and closer to our x-axis because we're dividing by the same number, fixed cost, by a growing quantity. Right? So it's always going to go down towards it, but it's never going to hit zero because even if I divide my $200 of fixed cost by 1,000,000, it's still going to be greater than zero. Right? An average can't be zero or negative. All right, so that's average fixed cost. Average variable cost is a cost of variable inputs. What's a variable input or variable resource? It's a resource that increases when my quantity increases and decreases when my quantity decreases. So if I want to make more pizzas, I need to hire more people to make those pizzas. So labor and materials are normally the two that fall into this category, right? So when I produce more, then my costs go up generally, right? So cost of variable inputs is average variable costs, or my average variable cost, not average variable D, whatever that is, equals variable cost divided by quantity. And we'll see that variable costs actually follow our marginal costs. They go down at first, and then when marginal gets above it, average is pulled up, and it pulls it up in the future, right? So it kind of creates this bowl shape here, right? And we'll talk about why, but pretty much the idea is the marginal cost decreases at first because we're dividing our change in cost, which is pretty constant, by a growing number of output because of that increased output or increasing returns region we talked about before. Right? So it goes down, then goes back up, and that pulls down our average. And then once it intersects at the lowest point, it pulls up our average, creating the bowl shape. Then we have total costs. Total costs are fixed costs plus variable costs. Those are all the costs. So put them together, add them together, it gives you your total cost. You can find this by doing average total cost equals total cost divided by quantity. Or you can simply add average variable cost and average fixed cost, and I'll give you your average total cost. Right? And we'll see that here is another bowl, right? It gets that bowl shape from the AVC. And the distance between these two, the distance between average variable cost and average total cost, is the same as the distance between average fixed cost and the x-axis, because average variable cost plus average fixed cost is what pushes the average total cost up higher. It's the bowl stacked on top because it's always going to be greater than the average variable cost because it's the sum of both AVC and AFC. Okay, then we have marginal cost. Marginal cost is a change in total cost divided by the change in input. Change in total cost divided by the change of input. In other words, it's the cost of one additional unit of output, right? Cost of one additional unit of output. I'm sorry, this shouldn't be change of input. This should be change in output. There you go. Change in total cost divided by change in output, right? So the cost of one additional unit of output. So how much does it cost me to produce the next unit? Well, at first it costs a lot less. It goes down at first, creating this Nike swoosh, because the first couple of people I hire are really productive. They cost the same as the 16th, 17th, 18th person, but they're way more productive. So my change in total cost is not very significant. Change in output is very significant, which pushes the number down. It's a lower number because the denominator is greater than the numerator. So it goes down at first. But then diminishing returns kick in. We realize that as we hire more and more people, the cost doesn't change, but the output I get, or additional output I get, is lower and lower and lower, making the number rise and creates this swoosh. Because it's a marginal, marginals pull down and change the averages. So if marginal is less, then the average is less. If the marginal is greater, then the average is greater. All right, sorry, I got interrupted there if the video looks a little weird. So those are short-run costs. That's what they look like on a graph. You should be able to draw those and see them. You won't have to draw them, but being able to draw them shows that you know them. All right, so now we can go from those variable costs and we can calculate total costs from them. So the first thing you do when you have all these curves, they look like gobbledygook, nonsense, right? The first thing you do is draw a vertical line for the quantity from the bottom to the top, right? And then that will tell you everything you need to know. These are all plotted points, right? That's why these graphs look this way. So if you know your quantity, then you can find the plotted point, and that will give you the information you need to. So you draw the plotted points. To find the marginal cost, is simply dash up from 5 all the way until I hit the marginal cost curve, right? That's the plotted point for marginal cost at quantity of 5. So my marginal cost for 5 is going to be $20, right? So the additional cost to produce the 5th unit is 20 bucks. Then I dash up until I hit the ATC to find my average total cost. So if I go up from 5 and I hit the ATC right here, I dash over, my average total cost is 14. How do I find the total from that? I simply take 14 times the quantity. Remember, the average is simply the total cost divided by quantity. So I multiply, I get back to the total. 14 times 5, or what's that, 50, 70? $70 is going to be my total cost. That green box right there, large box. And then how do I find my average variable cost? I dash up from here until I hit AVC. I dash over, that's 12. My average variable cost is 12. What's my total variable cost? It's going to be 12 times my quantity of 5. 12 times 5, or 60, this smaller box here. Then finally, to find my total fixed cost, I dash up until I hit AFC. I dash over, my average fixed cost is going to be $2, right? My total fixed cost is going to be my $2, or average fixed cost, times my quantity, so 2 times 5, or 10. I can also find that same number by looking at the distance between my ATC and AVC curves, right? If I do the distance between them, it'll also be 2. All right, questions about that? Hopefully that makes some sense. Hopefully that's helpful. Let's look at one more thing, and then our next one we'll do some practice with a chart, and we're almost done. All right, so how do you analyze these? Well, remember that the average fixed cost is the vertical distance between AVC and ATC, right? AVC and ATC, this vertical distance is the same as this vertical distance, the distance between x-axis and AFC, because AVC plus AFC equals ATC. All right, also remember that marginal cost will intersect average curves at the lowest or minimum point, right? So when it impacts or intersects this AVC right here, when marginal cost is lower than AVC, it's going to pull it down. And when the marginal cost or the additional cost of the next unit is greater than AVC, it's going to pull it up. Same thing with ATC. When it's below it, it's going to pull it down. When it's above it, it's going to pull it up. Right? So it's the same idea as if, I have the average height of the class, and then Mr. Peters walks in. The marginal height is very high, right? He's a tall dude, right? So it's going to pull up the total average in the class. The marginal is greater than it, it pulls up the average as though they're attached by strings. Okay, so keep that in mind. And then finally, know that AFC always gets closer and closer and closer to the x-axis, but it never touches it. And because that distance is the same as this distance, ATC and AVC are always going to get closer and closer and closer, but never touch. The reason is the fixed cost stays the same, is divided by a greater and greater quantity, which means that the average keeps getting lower and lower and lower, but an average cannot be 0. Okay, hopefully that was helpful to you. Those are our cost curves. Next, we'll do actual chart practice of calculating these things.